All right, so today we are going to talk about functions in R, and you've already had to deal with functions for your first homework assignment. I'm still finishing up the instructions for your second homework assignment. It's going to be a little bit more involved, a little bit more. You've got to write more functions, and so today's lecture will cover just some basics of functions, and then also a little bit of strategy for writing a function, okay? All right, so here are some basics here. Whoops, I don't want to do that. Okay. You write a function like this, right? You say, you give the name of your function, and then you make the function call, you use the function, I guess, okay? Inside you put the argument names, and then you write whatever expressions you have. At the end, you have some kind of output object, and you often can throw that in return, or you just make it the last line, okay? And then, and that's how functions work in R, okay? All right, and so if, generally functions are put inside curly braces, but if there's only one line to the function, you can actually leave off the curly braces, all right? General style recommendations, so style guidelines say you should always use the curly braces, okay? Functions themselves are objects, so you can treat them like objects. So you can throw it into a list, and here I've got a list, and the first item is a function. And then if you ask R what is the type of this object, it gives it the name of closure, okay? It's a little bit of an unfortunate naming convention, but that's what it is, okay? When you write your function, if you don't explicitly use return, it's going to return the very last line of the function. So in this case, there's only one line in the function. This is the last line. It's going to return the value x times x. Okay. So we will call things explicit return values and implicitly return values, okay? And this is basically the same exact function, but here I use return, and here I don't, but they're going to operate the exact same way, because here, this is the last line in the function. There's only one, and it's the first and last line, and so it's going to return that value x times x, okay? This is actually the recommended style, is that you don't use, if you're going to return the last line in your function, the recommended style is not to use the word return. So when do you use return? You use return somewhere earlier on in the function, okay, if you're going to return an early value. As soon as a function is running, when the function's running code, as soon as it hits return, that is a give this object back, your purpose has been fulfilled, and stop, okay? So once code hits a return, okay, and it returns an object, nothing after the return will be executed, okay? You can put all kinds of stuff after the return, but as soon as it hits return, the function is done, okay? The purpose of a function is to return an object, and as soon as it returns an object, its purpose has been fulfilled, and it's done, okay? And but anyway, recommend style is this is how it goes, right? In R, functions can return only one object, okay? And so if you want to return more than one value, you have to combine them together into a single object. Either you combine them into a vector, or you combine them into a list. All right, so here I want to return x, x squared, and x cubed, and so I combine those three values into a list, or not into a list, into a vector. And again, this is the only value inside, only the last line of the function. So that is the value that's going to get returned. I run f on 2. It returns 2, 4, and 8, as we would expect. Here's the same idea, but now we're going to return a list. So I've got list, and this is a named list. So I have x is x, square is x squared, cube is x cubed. And it returns this list. Okay. Okay. All right. So yes, functions can return only one object, and so if you want to keep track of multiple different values, we often recommend making a list. Okay. When you define your function, you are at the same time defining argument names. Okay. And when you call the function, you use these names to enter the values, right? So here's just a very simple function where it's going to take in 3 arguments, x, y, and z. And what it's going to return is it's going to use the paste 0 function, which pastes strings together. It's going to coerce everything into strings, paste them together, and then return that string that it's constructed. So basically it just takes 1, 2, 3, plugs in x is 1, y is 2, z is 3, and it returns back this string. Yes?
Do functions in R pass by reference or value?
Pass by reference or value? I want to say pass by value. Wait.
Okay.
Yeah. Okay. So when you call the function, you can specify the names themselves. Okay. Supply them in any order. Right. So here I'm calling the same function, but this time I'm saying z is 1, x is 2, y is 3, and so when it pastes it, it uses the correct values in the correct order. Okay, x is 2, y is 3, z is 1. Okay. If you only specify the names of 1 or 2 arguments, R does its best to match them. If you give the name of an argument that's not part of the function, R is going to give you an unused argument error. Right. So you got here I got y is 2, and then I give it 1 and 3, so it tries to match up accordingly. So 1 goes to the first value, and 3 goes to the other value that's not specified. And here I've got y is 2, and the number 1, and x is 3, and it tries to match them accordingly. Okay. And here I've got f of 1, 2, 3, m is 1, and it gives me an error, unused argument, m is 1. All right. This is all straightforward enough. When you run a function, okay, you need to have, it needs values for everything, otherwise it's going to complain that it doesn't know how to run the code, right? So here, so every value that's used inside the function needs to have, or every argument used inside the function needs to have a value. So in this case, I'm writing a function that goes x, y, z, and w, okay? But as far as the function code itself, it only uses x, y, and z. W is not actually used in this in the one expression inside the function. So here, I call it with all 4 arguments defined, 1, 2, 3, and 4, but W4 is not used anywhere here. So it runs, okay, and it doesn't complain about there being an unused argument, okay, because W is part of the function definition, okay. Here I run it with 1, 2, and 3, and I don't give it a value for W, but the function still runs because W is not actually used anywhere inside the function. Okay. Again, here is the same function that we have, but this time I'm saying x is 1, y is 2, and w is 4, and I did not give it a value for z. All right. So in this case, we get an error, right? Argument z is missing. Okay, it cuts off part of our line here, but it says argument z is missing. Okay, and so because we're using z in here, the function needs to have a value for z. And so to kind of avoid that, one thing you can do is you can provide default values for the arguments using the equal sign, right? So in the definition of the function, you can say by default x should be 1, by default y is 1, and by default z is 1. Okay, and in this case, now you can call the function without providing any values. So I just call f with no values inside, and it's going to use the default values for everything here. Okay. And here I provided the argument 2, and so 2 gets put in for the first argument x, and we get this. I say z is 3, and it's going to plug in 3 for z, and it uses the default values for x and y. All right, so that's just all part of defining the arguments and using them accordingly when you make your function. All right. Values that are created inside a function only exist inside the function. This is a very key idea. We're going to explore this a little bit more on Friday when we talk about scopes and environment. But basically, when a function runs, it creates its own environment. In general, when you're working in R in the console, you're working in the global environment. But when you execute a function, it creates its own separate environment. And you might be working with values inside the function, but those values exist only inside the function. And as soon as the function is done, those values are destroyed, or they just disappear, okay? They don't go anywhere, they're not saved anywhere. If you want to save them, you have to explicitly get them to the output, right? So in general, with a function, you should not try to change values in the global environment from within a function. And then the other part is, yeah, if you want to get a value out of the function, it needs to be part of the output object. So you got to throw it somewhere into that list that's going to export all the values that you need. Okay. So here I have 10. 10 is defined in the global environment. Okay, that's your general workspace. And here I've got a function. F is just a function of x. It's going to update x. It's going to take our current value x and add 55 to it. Okay, and then this is the last line in the function. It's going to return x. Okay, and so I execute x. X is 10, and it returns 65. Okay, however, the value of x itself is unchanged. X remains 10. So if I wanted to update the value of x, I would have to store it, okay? So here again, x is 10. When I execute f on x, I get 65. X is still 10. The only way I update this is I say run f of x and store it into x, okay? And now x is 65, right? And so this is how we operate functions, is that when you run a function just like this, and it's not being stored anywhere, okay? It's just gonna output something onto the screen, okay? It's not going to save a value. No value should get updated anytime you run a function. And this is the case for anything, right? In 101A or something, you create a linear model, right? And if you do LM something, it's going to output something to the screen. But if you never use the arrow, like stored into model 1 or something, that work is lost, right? And I imagine you guys experience that. And then you say, oh, I have to save my model somewhere, right? So, and the same idea with R. If you just run a function and you don't have an arrow assigning the output of that function somewhere, that output just goes to the screen and then it's gone, okay? So if you want to save this value 65, you've got to assign that value somewhere. All right, so I want you guys to always be thinking about writing a function, okay? And this is my guideline, okay? Because I know as you code, there will be times when you've done a task and you say, oh, I need to do this thing again. And so maybe your default mode of thinking is just say, okay, I'm going to just copy this code that I wrote over here, paste it down here, make a couple changes, change from English to Spanish or whatever it is, right? And then it should work, okay? If you copy and paste once, that's fine. Copy and paste twice, that's kind of my limit. I'd say if you copy something and you paste it here and then you paste it again, that would be my recommendation, and say, okay, you shouldn't do any more copy and pasting. If you find yourself, you're gonna have to copy and paste it a third time, okay, then you need to turn it into a function, all right? I mean, this is just my recommendation, but I promise you it will make your life better, okay? If you've copy and pasted something 3 times, by the third time, you should not do a copy and paste. You should write a function, because it means you're basically doing the same thing. You're just kind of tweaking a few things, and by the time you're doing it a third time, write a function, okay? Because what's going to happen is later on you say, oh, you know what? I need to change something a little bit, okay? And if you've copied and pasted it several times, you're going to have to make that change like in 4 locations throughout your code, okay? And that, or more locations, and that's terrible. It's even something like if you have to make a plot for, like let's say you want to make the same plot for 6 different variables, okay? And you go, oh, it's not so bad. I just call plot, I call histogram, and I'm going to adjust the x-axis ticks, and I'm going to add a title and things like that, right? And you say, well, I can just copy and paste this, and I can copy and paste it 8 times, okay? But then later on you decide, oh, for all of these things, I just want to tweak something. Then you've got to go through and make that same tweak in all locations. It's much better if you just write a function that's going to create the plot that you want, okay? And then you just put into arguments the things that you might change, right? Like the variable name and stuff like that. Everything else you calculate. So that's my thing. So but if you're going to, by the third time you're going to copy and paste something, turn it into a function, okay? Copy and paste once or twice, I'll allow it, okay? All right, just some advice for writing functions, okay? Name your function to make it clear what the function does, all right? It's tempting to just call a function f, function g, function h, okay? But then your environment's going to be full of functions, f, g, and h, and you're not going to remember what each of these things do, right? So, so give it a name that makes sense, right? If your function is going to return a true or false, okay, my recommendation, the name should start with is, okay, like is prime, right? So if you want to check is a number prime and it's going to return true or false, it makes sense to name it is prime, okay? Because that's like a question, is it prime? Is it numeric or something like that? Is it whatever this thing that I'm checking for, true or false, okay? Is it greater than 5 or something like that? Your functions should be simple enough to be quickly understood. This is subjective, right? Some people can understand a lot more complex things quickly, and others can't. So this is I guess it's for yourself. If you can look at a function and quickly understand it, that should be kind of your guideline. If it's getting overly complex, maybe it makes sense to break the function out into a couple different pieces. Okay, and then guiding principle. It's better to change code in one location, as in inside the function, than in multiple locations because you copied and pasted it. All right, so let's talk about some strategies when we write a function. Okay, so the example I'm going to use is bubble sort. Are you guys familiar with bubble sort? Maybe kind of, yeah. Okay. Like multiple, I don't know if you've seen this and it's been beaten to death too often. Okay, so just straight from Wikipedia, it says, starting from the beginning of the list, compare every adjacent pair, swap their positions if they are not in the right order. That is that the latter one is smaller than the former one, and then after each iteration, one less element, that is the last one, is needed to be compared until there are no more elements left to be compared, okay? So, so here's just an example. If we've got a vector 5, 1, 8, 2, 4, this is how it works. We compare 5 and 1, and we go, oh, 5 is bigger than 1. These two numbers are in the wrong order. So we swap their orders, and we go 1, 5, 8, 2, 4. Okay, that's how it goes. And then we go to the next adjacent pair of numbers. We go 5, 5 and 8. So we got 1, 5, 8, 2, 4. We compare 5 and 8, and we say, well, okay, those two numbers are in the correct order. 5 is less than 8. That's in the correct order. Okay, we go to the next adjacent pair. 1, 5, 8, 2, 4. Okay, and we say, okay, these two numbers are in the wrong order. 8 is bigger than 2. So we swap those locations and we get 1, 5, 2, 8, 4. All right, and then we compare the last thing and we compare 8 and 4, and then we say these are in the wrong order. We swap them, and we get 15248. That's the end of the first pass, or the first sweep, okay? And now that we've done this, we know that the rightmost position is going to be the largest value, okay? That the largest element is all the way to the right. We can lock in this value, okay? So at the next iteration, I've locked in the number 8. We know that the first pass will bring the largest value all the way to the end, okay? And we do the same thing. We go we compare 1 and 5, okay? 1 is less than 5, so we're not going to do a swap. We compare 5 and 2, okay? 5 is bigger than 2, so we swap, okay? So now we're at 1, 2, 5, 4, 8. And then we compare 5 and 4, and then we swap those, and we get 1, 2, 4, 5, and 8, okay? And so at this point, we know 5 and 8, okay? And we don't have to compare 5 and 8, because we know 8 is already locked in, okay? So we only have to do 3 iterations, or three checks in this sweep, okay? So we lock in 5 and 8, and so now I do 2 checks, okay? I'm going to compare 1 and 2. Those are in order. And then I check 2 and 4. Those are in order, and so now I can be confident that 4, 5, and 8 are in the correct position. I mean, the thing's already sorted, but the algorithm's still running, okay? So 4, 5, and 8 are in the correct spot. Now we just compare 1 and 2. No swap. This is in the correct order, and then so now we can be confident that 2, 4, 5, and 8 are in the correct spot. And if the last 4 are in the correct order, then that means the 5th one is also in the correct spot as well, okay? And so now this is our 4th and final pass, and we've gotten everything in order, all right? So this is known as bubble sort, okay? And I think it gets its name because as the algorithm runs, the largest values kind of bubble to the top, whereas in they get pushed to the end, okay? So we kind of go through until we get the largest value, and it pushes it to the right, and then the next largest value, 5, gets pushed all the way to the right, and so on and so forth. All right, is that okay? All right, so how would we code something like this in R, okay? So we want to write a function. So the goal is, let's write a function that's going to perform bubble sort, right? Oh, here's a little, let's just watch this little animated animated GIF. Did everyone respond to the online poll? Everyone's good? All right, I'm going to go ahead and close this. Yes? Oh, you still, okay, and let me click cancel. Thank you. All right. All right. Okay, so here, how do I zoom into this? Okay, so here it starts with 6, 5. Those are in the wrong order. It swaps. Then it compares 6 and 3. Oh man, this thing's gonna take a while. Okay, so it swaps 6 and 3. It compares 6 and 1. Okay, and it says I gotta swap this. It compares 6 and 8. That's good. Okay, 8 and 7, wrong order. So it swaps those. 8 and 2. There's no fast forward button, huh? Okay. It swaps those. 8 and 4. It swaps those. Okay, and then 8 is now locked into position. Okay, so we don't have to go through. So it's we'll just watch 2 iterations of this. Okay, we'll push the 7 all the way to the right, and then we'll call it a day. Okay, and then so it keeps swapping all of these things. All right, so the 5 gets pushed over. 5 and 6 is in, that's good order. 6 and 7 are in order. 7 and 2 are in the wrong order, so it's going to swap those. Okay. 7 and 4 are in the wrong order, so it swaps those. Okay, and then now 7 is locked in position. Okay, and we repeat this until the whole thing is done. Okay, can I close the poll now? Okay, great. Oh, something happened there. Okay, all right, that's fine. We'll allow it here. Okay. Where did the thing go? Okay, so here is, I mean, any task, big task, can always be broken down into smaller tasks, right? And this is just motivation for life, right? You want to I don't know, what is it? I don't know what the phrase is. I mean, you know, right? You want to build a castle, you got to start with one stone, okay? You want to accomplish anything, you got to break it down into smaller tasks and just start with the smallest task, right? And so as far as bubble sort goes, I'm going to just break it down to really, really, really small steps, okay? All right, and then we're going to build up our code using this. Yes, is there a question? Okay. All right, so what I'm going to do is one of the tasks that we need to do is we need to compare two adjacent values and swap them if they're not in order, okay? And so that's going to come down to just comparing adjacent values. That's simple. That's an if statement with a comparison. And then swapping the two adjacent values. So we got to think about how to do that, okay? And then the other part is we need to perform multiple sweeps on a vector. Each time we perform a sweep, we have to do one fewer comparison, okay, or comparison swap thing, okay? So each sweep just comparison swaps for all of the positions that aren't locked, and then the following sweep will have one more position that's locked, okay? So this is kind of how I'm going to break down our task, okay? And so this is my advice, okay? Do not immediately start writing a function, okay? So let's say we just want to try, let's try swapping the first two values, okay? That sounds like a simple task. Let's try making a function, okay, for swapping the first two. Okay, if you do this, you might say, all right, well, let's take the value in the second position, put it in the first position, and take the value in the first position and put it in the second position, and then return the resulting vector x, okay? And then so here x is 5, 4, 3, 2, 1, and then I run swap the first two, and I get 4, 4, 3, 2, 1. And I go, huh, that's not what I wanted, because if I swapped 5, 4, 3, 2, 1, if I swap the first two values, I should get 4, 5, 3, 2, 1, okay? And here's the problem with going straight into writing a function, okay? All of the values inside the function exist only inside the function. There's no way to kind of debug what's happening inside of a function, okay? So my recommendation is work directly in the global environment, okay? Don't see if you can get your code working, okay, in the global environment, and then once you get your code working in the global environment, then put it inside a function, okay? At that point, all you have to just write is like a function at the top, put the return value at the end, and then curly brace, okay? But you want to get your code working inside the global environment. And every time you work in the global environment, you should kind of clear everything out, okay? So this is my recommendation, right? You want to get your basic algorithm idea working in the global environment. And the reason for this is that if something doesn't work the way you want, you can see what value everything has in the global environment, right? The global environment, you can explore all of these values. These values don't get deleted when the function finishes running, and it helps you in the debugging process, right? But the important thing here is that every time you do this, you got to delete everything out of your global environment, right? So I would say, you know, at the top of your script, put in this command, right? rm is list equals ls. That deletes everything, that clears everything from the global environment, okay? So here I'm going to start. I'm going to just say, all right, why didn't this code work, right? X is 5, 4, 3, 2, 1. And I want to put the second value into the first position. All right, so 5, 4, 3, 2, 1, I do this, and indeed the second value was 4, and it ends up in the first position, okay? And then now we start to realize why the second line didn't work is that when I say take the first value and put it into the second position, we see the first value has now been overwritten and has the value 4, and so if I take this value and put it into the second position, 4 just goes into the second position, and I don't have the swap. It's not 4, 5, 3, 2, 1, but just 4, 4, 3, 2, 1, okay? All right, so how can I solve this? Well, what I need to do is I need to save that value 5 somewhere, or do something, right? So this is what I'm going to do. So here, before I take the second value and overwrite the first value, okay, I'm going to store it into just a location called temp, okay, like a temporary location. So again, to kind of work through this, I delete everything in my environment, okay? I create my vector again, 5, 4, 3, 2, 1, and I'm going to say take that first value stored into the temporary location. Take the second value, put it into the first location, okay? And now take the temporary value and put it back into the second location, all right? And so when I check X, it works, okay? 5 and 4 have been swapped, and now I have 4, 5, 3, 2, 1, right? So I started off with 5, 4, 3, 2, 1, and now I have successfully swapped the first two values, 4, 5, 3, 2, 1. And again, I was able to figure out what I was doing wrong is because I'm working in the global environment and not inside a function. Again, once you put things into a function, it's like putting it behind, like, you know, some curtain that you can't really peek inside, okay? I mean, there is like a debugger tool in R and stuff, but this is easier to deal with. Okay, all right. And then so once you get something to work, you should say, all right, does it work for other things? So I have the exact same code that I had before. I have the vector 1 through 8. Okay, and indeed it swapped the first two values. The first 1 and 2 got swapped, and now I have 2, 1, and then 3, 4, 5, 6, 7, 8. Okay, and so now I want to incorporate the aspect where we're going to check and only perform the swap if they're in the wrong order, right? So if the first value is bigger than the second value, then we do the swap. Otherwise, we don't do the swap, right? So all I'm going to do now is I'm going to take this code and just put an if statement around it, okay? So we're going to build up our code, and then we're going to condition the swap, okay? So here, we're just going to say, all right, here I've got 5, 4, 3, 2, 1, and we should swap the two values because the first two values are 5 and 4. And so all I'm going to do is put an if statement, okay? If x1 is greater than x2, and then this is the code to do the swap, okay? x1 goes to temp, x2 goes to x1, temp goes to x2. So this is the code to do the swap. And then when we check if it ran, indeed, they did swap 4, 5, 3, 2, 1, okay? And anytime you change your code, you should do more test cases. You should make sure that it's doing the thing that you want it to do, okay? And so this is an important strategy, is that anytime you make a small change, just say, all right, is this gonna work for this thing, okay? So here, we've got 5, 4, 3, 2, 1, we run it through, okay? There's no function here. Again, I'm just working straight in the global environment. I always start off by deleting everything in the global environment. And we just created the X, we run the code, and indeed we swapped, okay? And then so here, again, I wipe everything out of my global environment, and now I create the vector 1, 2, 3, 4, 5. And in this case, we don't actually want to swap the values 1 and 2, because they're already in order. So when we run this if statement, the if statement is not true, so it's not going to run this. And indeed, nothing is swapped, and it's 1, 2, 3, 4, 5, right? And so, you know, you test a few more cases, but, you know, for the sake of the lecture, I didn't do any more of these things, okay? All right, and so now what we want to do is we want to build up. So we've got this kind of part working, right? We've got two adjacent values, at least just for the first two values, right? So what we want to do now is we want to say, all right, let's do a sweep. Let's do one sweep, not all multiple sweeps, but let's just do one sweep across the vector, okay? So to do this, we're going to perform a sweep. None of the positions are locked in the first sweep, okay? And all I'm going to do is we want to repeat this task of swapping things multiple times. So I'm going to just take this and put it inside a for loop, right? So I'm going to say, okay, here's my vector, okay? My vector has a length of 5 or something. All right, so let's go ahead and do a swap for the first value, then the swap for the second, third, fourth, and fifth values, okay? All right, so all I did is I took my swapping code, okay, and then I replaced, because I'm going to do a for loop for I in sequence length of x, right? So the x is a vector of length 5. I'm going to do sequence length, 5, which is going to go 1, 2, 3, 4, 5. I'm going to do for I in 1 through 5, basically, okay? And I'm replacing all of the 1s with an I and all of the 2s with an I plus 1. Okay, does that make sense? All right, so I change, all I do is I take this code that worked for case 1 and 2, and then I just replace I with 1 with I and 2 with I plus 1, and I say, well, let's throw that into the for loop and do it for basically I 1 through 5, but I'm using sequence length here, okay? Okay, and so when I run that, okay, again, I'm in my global environment. I wipe everything out, start off with a vector 5, 4, 3, 2, 1, and I run that exact code where I've replaced the 1 and the 2 with the I and the I plus 1. When I run it, I get an error, okay? I get error missing value where true false needed. So what is going on here? So it's the I plus 1, right? So again, if you ran it inside, if you put this inside a function, okay, you're going to get the same error, except you're not going to be able to investigate what happened, what went wrong, okay? So now that it's in the global environment, I still have access to X, I still have access to the value I, right? So when we got missing value or true false needed, I can say, all right, it actually tells us which line of code is giving us the problem, right? It says if xi is greater than xi plus 1, so we can say, all right, let's look up what I is, let's look up what xi is, and let's look up what xi plus 1 is, right? So we see I is 5, xi is 5, xi plus 1 is na, right? And we go, well, if I is 5 and I plus 1 is 6, yeah, that makes sense, that there's no sixth value in my vector, and that's why I'm getting an na, and this is causing my function to break, right? And so by working in the global environment, I'm able to take a peek, right? Some of you guys are already very proficient in your coding, and you identified this problem, you know, as soon as I put it up on the earlier slide, okay? But by taking a look here, we have an idea of where the problem is, and so now we say, okay, well, how can I fix this, all right? Well, for a vector of length 5, I don't actually need to do 5 swaps, I only need to do 4 swaps, right? So rather than going 1 through 5, I should actually go 1 through 4, okay? Or my sequence length should be the length of my vector minus 1, okay? So it's just a minor change, and I take the exact same code that I had before, but I change my sequence length from the length of the vector to the length of the vector minus 1, okay? And then again, wipe everything out of my environment, create vector 5, 4, 3, 2, 1, and I run the code, and indeed, 5 gets pushed all the way to the right, right? Is that okay? All right, and then so this is working, and then we just say, all right, let's test the code, make sure it works for other cases, right? And this is what you want to do. You don't want to, just because you get one victory, you don't want to say, all right, it's great, okay? You want to give it a few more test cases to make sure it actually is working the way you want it to work, right? And this is going to be the difference between an okay coder and a strong coder, is that the strong coder is able to think of a variety of test cases, okay, especially edge cases that could cause things to break, okay, and that's just a skill that comes with more practice, right? The more things you encounter, the weirder things you encounter, you say, all right, these are test cases I need to be thinking of, right? So anyway, I just create a vector 1, 2, 5, 8, 3, 6, and then I run it through here, and indeed, the 8, the largest value, gets pushed all the way to the right, okay? So same exact code, my second test case works, all right? So I'm able to perform one complete sweep, okay? And so now I say, all right, the last thing that I need to do is I just need to perform this sweeping action multiple times, right? Where I kind of just do this comparison, and the thing, the largest value bubbles to the top, right? So, okay, here's another test. I did sample 10, and then, yeah, indeed, 10 gets pushed all the way to the top. Okay, and then so the last part is we're going to perform multiple sweeps on the vector, and then every time we do a sweep, one more position is locked, okay? So all I'm going to do at first is I'm going to just say, well, let's just do a whole bunch of sweeps. So I'm going to take this for loop and put it inside another for loop, okay? A double nested for loop, which, you know, isn't the most efficient method, but then again, bubble sort is not the most efficient sorting method either, so it's fine, okay? And so all I've done is taken the exact code that I had before. This is the exact same code that I had before. I haven't changed a single thing, and I just put it inside another for loop, okay? in this for loop, I just say, kind of learning what I did before, I say, well, if I've got a vector of 5, how many sweeps do I need to perform? I should perform 5 sweeps, okay? And so, four sweeps, okay? If I perform 4 sweeps, then it should work. And so I just do for, S, and basically each sweep, I'm going to do 5 minus 1 sweeps here, okay? And it works. 1, 2, 3, 4, 5. I put in 5, 4, 3, 2, 1, and it works, okay? And so this, actually, we could be done here. This is not the true bubble sort algorithm where we're doing one less, where positions are getting locked. We're just saying, as far as this bubble sort thing goes, it's just continuing the thing, and rather than locking in 7 and 8, it's going to do the comparison between 4 and 7 and say they're in correct order, and then it does the comparison between 7 and 8 and says that's also in correct order. And so it's not as efficient, but it works, okay? All right, so let's say I say, I want to implement the true bubble sort algorithm.